All right, let's look at yesterday's assignment. We want to fill out an XY chart and graph each of the following functions. So we're going to start with f of x equals 1/2, and these look like to me, and I don't have my glasses, so we're just going to go with this. These look like floor functions. I think I see little feet on the bottom. I don't know why they make it so small, but they do. So I'm going to call all three of these floor functions. All right, so I pick some numbers, and I usually start with 0 because 0 is easy, and then I skip 1, I go to 1, I skip a box and go to 2 for my x values, and then I fill in something in between 0 and 1. I'm going to choose 1/2, and something between 1 and 2, I chose 1.5. So I'm going to substitute in 0 for x. We want the floor of 0. The floor of any integer is that integer. So the floor of 0 is 0. And 0 times 1/2 is 0. So I've got a point I can plot, but this is not a linear equation, so I'm not going to plot this point just yet. All right, the next number that I'm going to use is 1/2. So the floor of 1/2, we're going to drop down. If you need to draw a number line, draw it. Okay, there is 0 and there is 1, and 1/2 is here. It's going to drop down to 0. So again, we have 0. We take the floor of 1/2, and 0 times 1/2 is 0. Okay, so that looks like we're on the same step here. Let's go over to 1. 1 times 1/2 is, I'm sorry, the floor of 1, I'm jumping ahead, is 1. The floor of any integer is 1. And 1 times 1/2 is 1/2. So that's 0.5. All right, then I'm going to look at 1.5, so that's going to be up here on my number line. I want the floor of 1.5, so that's going to be 1. 1 times 1/2 is 1/2, or 0.5. Then I'm going to go to 2. The floor of 2 is 2. 1/2 times 2 is 1. So you can see this is one step, this is one step, and now I'm starting the third step. All right, so let me plot 0, 0, and remember for a floor function, that solid dot is going to be on the left. So I'm going to start at 0, 0, make it solid, and I'm going to go to 1/2, which is right here. It's going to be really hard to see, but remember that's an open circle, and then that step is going to be all those points in between. Then when I'm at 1, oops, that circle needs to be at 1. All those points in between. When we get to 1 though, okay, we're going to jump up to 1/2. So we start another solid line, and then at 1 and 1/2, still on that step, so we can connect those. Still on that step till we get to 2. And then at 2, we're going to leave it open. We're going to jump up to 1. Start the next step. So you can see the pattern. You're going to go up by 1/2 each time. And if you remember, in the lesson, 1/2 is going to squish down those steps. Okay, make them closer together. So for here, we have a -1 on the outside. So let's do the floor of 0 plus 2 is 2. The floor of 2 is 2. And then multiply by -1. So we get a -2. Then at 1/2, 1/2 plus 2 is 1 and 1/2. The floor of 1 and 1/2 is 1, so that would be a -1. Put a 1 in here. 1 plus 2 is 3. The floor of 3 is 3, so that would be a -3. Am I doing that right? I don't think I have that second one right. Let me go back and look at that one. All right, 1/2 plus 2 is 2 and 1/2. I said 1 and 1/2. And the floor of 2 and 1/2 is 2. Okay? But we've got to multiply it by a -1, so this would be a -2. All right, now let's look at 1. 1 plus 2 is 3. Okay, and the floor of 3 is 3. Multiply by -1 and you get a -3. Now go to 1.5. 1 and 1/2 plus 2 is 3 and 1/2. We want the floor, so we're going to go down to 3 and multiply by -1. We still get -3. So I kind of see a pattern here. I see what my steps are going to be. It should jump up or jump down to -4 here. Okay, put 2 in here, plus 2 is 4, and then multiply by -1, and you do get -4. So let's plot that. 0, -2. Remember, on a floor function, we're going to start with the closed-in circle. We're going to be moving to the right. Okay, so we're going to go to 0.5, and that's going to be solid. Still going to be on that step. Then when we get to 1, that's when we have an open circle, and then we jump down to -3. Color that in, and then at 1 and 1/2, we're still on that step. Keep going. When we get to 2, it's going to jump down to -4. So keep that open. Make it solid here. So here's what your pattern looks like, and you should be able to repeat it going this way, and even go down again one more. Okay, now let's look at the last one. All right, I've got 0 times 2 is 0. The floor of 0 is 0. Minus 4 is -4. Okay, now we've got 1/2 of 2. 1.5 times 2 is 1, and 1 minus 4 is -3. Okay, let me slow down and show you that. 2 times 0.5 is 1.0, or 1. So the floor of an integer 1 is 1. 1 minus 4 is -3. So let's go up to 1. Put a 1 in for x. 1 times 2 is 2. The floor of 2 is 2. 2 minus 4 is -2. I'm not seeing those steps. Okay, this is going to be harder for me to do. I'm going to have to put a lot more numbers in there. Okay. But I think it's going to look something like this. Go ahead and graph that. We're going to graph that in Desmos and see if that's what we get. 0, -4 is where we start, and then we go to 1/2, and then we get -3. So that's where it jumps up, I believe. Okay, now we're going to jump up on the next step when we get to 1. Solid line. Then when we get to half increments, it's going to jump up each time. All right, let's look at the ceiling functions. Make sure that I get that where you can see it. All right, I've already put in the same type of numbers, 0, 1, and 2. That just works for me. And then something in between 0 and 1, and something in between 1 and 2. And then I work this out by putting 0 in to the ceiling function. 0 times 1/2 is 0. The ceiling of any integer is that integer. So that's going to be 0, and then add 3, and you get 3. Then I'm going to go to 1/2. 1/2 of 1/2 is 1/4. Since we're doing ceiling, we're going to go up to 1, and 1 plus 3 is 4. We start with 1/2, we get 4. So now I'm going to put in 1. 1 times 1/2 is 1/2. The ceiling function moves that up to 1. 1 plus 3 is 4. So I can see my steps. I'm going to go up to 1 and 1/2. That's going to be 3/2 times 1/2 is 3/4. That's still going to have a ceiling of 1. 1 added to 3 is 4. So this looks like a long step. Okay, and then I'm not sure where it changes. Maybe it changes at 3 up to the next step. Let's try that. So 3 times 1/2 is 3/2. 3/2 is 1 and 1/2. The ceiling is going to go up to 2. Okay, and then 2 plus 3 is 5. So yes, that step finally jumps up to at 3. So let's plot that. 0 3. Ceiling function is going to start off solid on the left, and then it's going to be open. I'm sorry, solid on the right, and it's going to be open on the left. All right, so at 1/2, we're going to jump up to solid on the right, and it's going to be open on the left. Now we don't have this complete step here. We've got to use this step to see how long it's going to be. All right, so at 1, okay, no, at 1/2 is where it jumps up to 4. So I'm going to open it here. It's going to be solid here. Okay, and it's going to go over 1, 4. Okay, so it's going to go over here, and then 1 1/2, 4. It keeps moving, and then 2. It's still at 4, and then finally when we get to 3, it jumps up. So it's going to be solid right here and open up here. Okay, so we can kind of follow that. I'm just sketching this in. All right, let's look at, kind of sketch this function. All right, we want the ceiling of -x. So the ceiling of 0, because 0 is not positive or negative, is 0. 0 minus 4 is -4. The ceiling of 0.5 is going to be, and we want negative 0.5 or negative 1/2. So think about your number line with negatives. Is it going to be closer to 0 or negative 1? Negative 1/2 is right here. So that's going to be 0 because it's going to go up. Okay, so that's still 0 minus 4. That's going to be -4. I made a mistake there. When we get to 1, we're going to have the ceiling of -1 is -1 plus -4 is -5. The ceiling of -1.5 is -1.5 is here. It's going to jump up to -1. Okay. -4 is -5. So we can see our step here. Well, what happens at 2? -2, the ceiling is -2, -4 is -6. So here are our steps. Let's graph 0, -4. Okay. And then 1/2, -4. Still on that step. It's going to be solid. And then 1, when we get to 1, finally, this is messy. When we get to 1, finally, it's going to be solid here, and then open at -5. 1, 2, 3, 4, we've got to go down. Leave that open. And then at 1 1/2, we're still on that step. And at 2, we finally go down to -6. It's going to be open. So we see the pattern, and we can repeat those steps. We can go up and repeat those steps. I kind of marked this one off just because I think we have enough practice. And you can use Desmos to graph and then check your work. All right, let's look at this last part. Let me make sure I've got this where you can see it. Okay, we're going to, we have the parent function f of x equals, is that ceiling or floor? It looks like floor, but I can't really tell. Okay, I'm going to call this floors. This is the parent function. We want to describe the transformation of g of x. All right, so what they're saying is, what happens when you multiply by 1/2 here and add to inside of those symbols, the floor symbols. All right, so for number 7, you can graph this, and you can graph the parent function and then graph g of x and see what happens. But when we have something inside, this is going to be the opposite. This +2 is going to be a shift, but it's the opposite of shift to the right. It's shift to the left. Everything inside is going to appear the opposite. And this 1/2 times the x is going to actually be like multiplying by 2. So it's going to make your steps longer or wider. Okay, if this were 2, it would shrink them in to 1/2. So this is going to shift to the left 2, and then lengthen your steps by 2. For this one, we're adding 4 on the outside, and then we have a -1 here. So think about what the video that you watched said, and then let's put that into play. All right, for this one, the -x, let's see what happens. Let's go to the +4. The +4 is going to shift to the left 4 units. Okay? And then the negative, what happens when we put a -1 in front of the x? -1 times x. Well, this negative is actually going to flip everything around. So if your graph looks like this, it's going to flip it like this. It's going to be a reflection. It's going to kind of make an X. I'll show you that in Desmos in just a minute. And then this last one, the -x is -1. So this is going to be, well, let's just look at these in Desmos. Let's graph them in Desmos. All right, so I'm going to turn everything off, and we're going to start with our parent function. This is the floor of x. So when we go, we're going to start at 0, go over to 1. That's our first step. You don't see the open circle. Open circle is going to be on the, let me think about it, floor. The closed circle is on the left for floor, and the open circle is going to be on the right when you're graphing. So now I'm going to do, let me see, g of x equals the floor of 1/2 x. This one right here is the first one we looked at, +2. So let me turn that on. So it does lengthen the step by 2, makes it twice as long. Compare the green step to the red step, and then it shifts it to the left 2 units. So if we start here, I'm going to shift it 2 units, then I'll start here. Okay, now let's look at the second one. G of x equals -x plus 4. Is that -x? I think so. Well, let me just turn on x plus 4, and then we'll put the negative in front of it. No, that is negative. The way I have to put this in the calculator is put the negative outside of the word floor, because we don't have those symbols that show up. All right, so what's going to happen if I take the negative out? It's going to just shift it to the left 4 units. So this would move this point over 1, 2, 3, 4 and start right here. But when we put the negative in front, it's going to reflect everything, switch it around, kind of makes that X shape. All right, now let's go to the last one. Let me turn this one off. And then this is going to be the floor of -x plus 6. Okay, so let me take that negative out. That plus 6 is going to move it to the left 6. 1, 2, 3, 4, 5, 6. And then that negative is going to flip it around and reflect it. All right, that's it for homework. Remember, we're omitting number 6. Put your name on the top and turn it into your teacher.